So of all the things that the Human Research Program is investigating, the biological consequences of radiation exposure is one of the major ones. Some of the reasons for that is that the health consequences following radiation exposure are very complex processes. It's difficult to quantify exactly how the radiation is interacting with tissue, and then it's even more complicated to try to quantify and determine what the long-term outcomes are going to be in terms of things like carcinogenesis, central nervous system effects, and detriment to the central nervous system.
The primary means by which radiation affects cells is by damaging their DNA. You can get breaks in the strands in the double helix, you can knock bases out, and the cell will make an attempt to repair that damage. Sometimes it's effective, sometimes it's not, and sometimes it'll actually get repaired, but in an error-prone fashion, so it's what we call misrepaired. So anything that sets into the genome in that way is a mutation, and the accumulation of mutations can potentially lead to cancer and take a non-cancerous cell, a normal cell, and make it transformed into a cancerous one, so that's a big concern.
So on Earth, there's a couple characteristic things that are different from space. One of them is that the type of radiation we experience on Earth is generally what we refer to as low LET radiation, things like gamma rays and X-rays. We also have the protective shielding of the Earth's magnetic field and the atmosphere, which shields a great deal of the radiation. And then finally, we have things like radiation protection concepts such as time, shielding, and distance. So we can reduce the time of exposure on Earth, we can reduce the distance from the radiation sources, and we can reduce the exposure through shielding. In space, a lot of those things are very different. So we have a very complex radiation field that includes things like protons and all the particles on the periodic table of elements. They're coming in at energies that are approaching the speed of light, and they're difficult to shield against. And they're always there. So the concept of time really doesn't make sense because you can't reduce the exposure in space except perhaps getting to Mars faster. You can't really reduce the distance at all because the radiation is everywhere. And shielding concepts for galactic cosmic rays are very difficult because of the energies involved.